So till now we have covered two modules. Okay, the first module, that was the very basic introduction of the thermodynamics, and second module was all about the temperature measurement and also the first law of thermodynamics. Okay, now we should move to another module. Okay, and if we go continuously as per the syllabus, now we should start module 3. Module 3 is all about the properties of pure substance. Okay, but I will not start module 3 now, but I will start module 4. Okay, because module 4 is somehow connected with the module 2 which we have discussed. Okay, and module 3 is totally a separate thing, and it is also a lengthy as well as very important chapter. So I am waiting that some of the lateral students join the college. After that, I will start the module 4 because I don't want that any student should miss that particular chapter. Okay. So if I teach that particular module now, then some of the students who have not taken admission till now or who will take admission later, okay, they might face difficulty. So I have decided that I will teach that particular module, that is module 3 later. Okay, and that module 3 is totally a separate thing, so it is not a problem. It is not interconnected with any other chapter. Okay, so you don't find any difficulty with that particular module wherever I will teach. So before moving to the module 4, let us quickly discuss few things which we already studied till now. It is important to not only study but to keep the things in our mind also. Okay, सिर्फ पढ़ने से नहीं होगा, जो पढ़े हैं उसको याद रखना भी जरूरी है. Okay, so as your continuous assignment exam is approaching, it is very soon, so I will suggest you to study properly. Okay, now I will ask you questions, please respond. Okay, so Pratik, Mandal, switch on your camera, all of you switch on your camera and ask me the question and give me the answer whenever I will ask the question. Okay? So Pratik, can you hear me? So Pratik, can you hear me?
Yes. Yes, sir. Yes, sir. I can hear you. Yes, sir.
Okay. Tell me what is the difference between path function and point function?
Sir, the path function depends on the initial and the final position, and another one does not depend on initial and final position.
Path function depends on initial and final position.
Yes, sir.
Are you sure? Subankar? Subankar, Bhomik? So Pratik has network issue, I think. Jinnat, what is path function, point function?
Sir, path function is any property that depends on the path taken by the system, and state function or point function is any function that depends on the final and initial state of the system.
Point function depends on the initial and final point of the final position of the system, irrespective of path. Okay, give me the example of point function and path function.
So path function can be work, and yes, sir, and point function like potential or temperature.
Temperature. Other than work, what could be path function?
Sir, entropy maybe.
Entropy.
Sir, I think.
How entropy is path function?
Sure, I have no idea.
Subankar. Sorry, Supratik. Supratik. Supratik, can you hear me? Supratik Mandal, can you hear me?
Yes,
I
sir.
think you have network problem.
Sir, I can hear you.
Okay. Give me the example of path function and point function. Supratik, give me the example sorry, of path function and point function. क्या हुआ? Subankar, can you hear me? Subankar, can you hear me? Okay, point function density, path function heat. Okay. What is intensive and extensive property? Subankar, can you hear me? Shubhankar, please reply. If you are you able to listen to me or not?
Yes, sir.
I am asking what is intensive and what is extensive property. What do you understand by intensive and extensive property? What is intensive and extensive property, Shubhankar? Is my voice clear or not? Three students are there. Out of three, two are saying that I am not able to listen to me. Sorry, you are not able to listen to me. Then how am I going to teach you? If you are not able to listen to me, then how am I going to teach? At least you should choose a proper place, no, where the network connectivity is good. It is not my duty to arrange the best place for you. It is your duty now. When you are attending the online classes, you should have proper arrangement. And from last 1 year, everything is going on in online mode. Still, if you don't arrange anything for you, then nobody can help. Zinat, what is extensive and intensive property?
So intensive properties are those properties that are independent of mass, and extensive properties are those properties which are dependent on mass.
Example?
So extensive properties like extensive properties are like temperature, and then no, so not temperature, it's intensive property. So intensive property, for example, which are independent of mass, density, and so extensive property like mass itself and weight.
Okay. What do you understand by isothermal process?
So isothermal processes are those thermodynamic processes that are in those processes temperature remains constant.
Temperature remains constant. And adiabatic process?
So there is no heat transfer between surrounding and
There is
system.
no heat transfer. How would you find out the work done in an isothermal process? What is the formula for the work done in isothermal process?
So Q is equals to W.
Sorry?
The Q is equals to W, sir. Heat done.
No, that is the first law of thermodynamics. I'm not asking that. I'm asking the work done formula. That is the PdV. No, work done is PdV. If you take the integration of that PdV function, then what is the final result that you will get?
So whole integration of P dot dV, sir. Like, so pressure is not constant, but then
Rose from state 1 to state 2. Okay.
yes.
From state 1 to state 2, the volume is getting changed from V1 to V2. Then, and pressure is constant. Okay. So, what you will get?
So then we'll get P into V2 minus V1, sir.
V into V2 minus V1. This is for constant pressure. But
Yes.
if we want to find for isothermal process, then okay, no problem. You can derive it by your own, but you should remember this value because in exam the direct question would be asked. And at that time you will not have that much time that you will derive the formula by your own. Okay, so you should remember this value. This formula, this thing is very, very important. Okay, it is P1 V1 ln V2 by V1. Okay, so these things you should know, and these things will only can be kept in your mind if you will practice more questions. Okay, I don't say that you should memorize this formula. No, don't study like a parrot. Okay, but solve some questions related to this based on this formula. Automatically, it will be fitted in your mind. Okay. Okay. Last question. What is enthalpy?
So enthalpy is energy.
So enthalpy is energy. That is okay. But if somebody asks you how do you define enthalpy, then what do you say? Just give me the mathematical equation of the enthalpy. H is equal to what?
Sir, there was one equation where in a sum I used Q minus W is equals to delta E, sir. Change in enthalpy.
That is Q minus U equal to delta. That is the first law of thermodynamics. H is equal to what? U plus PV. Okay, that is the internal energy plus pressure volume energy. That was the definition of the enthalpy itself. Sum of internal energy and pressure volume energy. U plus PV. Very important equation. Okay. And this enthalpy term will be there throughout the thermodynamics. Remember that. Okay. This will be used throughout the thermodynamics. बहुत बार आपको ये enthalpy term से पाला पड़ेगा. So Pratik,
Yes, sir.
what is heat
Yes,
and what is work?
sir. Sir, heat is a energy that is released when, sir, some friction takes place.
No, this is not the definition of heat. What is first law of thermodynamics? What is microscopic and macroscopic approach?
No, sir.
What no? If you don't tell these very basic questions, then how can we go further? Okay. How can we move from module 2 to module 3 or 4? Things will be complicated. Now, when you will move in the next chapter, the things will be complicated if you don't remember this basic terminology of thermodynamics. Okay, because these are the things that will be utilized further. आगे जो चैप्टर्स पढ़ोगे उसमें ये सब टर्मिनोलॉजीज फिर यूज होगी आपको, तो ये सब तो आपको पता होना चाहिए ना अभी, फिर आगे जाके फिर ये सब पता ही नहीं है तो फिर कैसे समझ में आएगा। इसलिए तो मैं अभी तक जो पढ़ाया उसको पूछ रहा हूँ एक बार। You should remember this thing, no? Otherwise, how? Okay, for ideal gas, internal energy depends on which function? Ideal gas में जो internal energy होता है वो किसके ऊपर डिपेंड करता है? कम से कम बहुत अंडरलाइन करके मैंने ये पढ़ाया था, कई बार बोला था। Very very important question. For an ideal gas, the internal energy depends on what? There is only one function on which the internal energy depends. For ideal
Temperature,
gas.
sir.
Temperature.
Temperature.
Only temperature. And enthalpy? On what function enthalpy depends? On what function? Enthalpy also depends on the temperature, because H equal to U plus PV. No, U depends on the temperature. PV is equal to RT. That means it is also depends on the temperature. So basically we can say that enthalpy also depends on the temperature. So for an ideal gas, enthalpy is also the function of temperature only. Only on the temperature the enthalpy depends. Okay. Very very important question for thermodynamics. Many times this question have been asked in MCQ pattern. Okay, so Pratik,
Yes, sir. Yes, sir.
what is the unit of heat?
Sir, joule.
Joule. And what is the unit of work?
Newton meter.
Newton meter. Newton meter and joule. Is there any difference between these two quantity, these two units? Is there any difference between joule and Newton meter?
So Newton meter is known as joule only.
So unit of work and heat are same.
Yes, sir.
Unit of work and heat are same. Don't be confused. Okay. One is considered as high grade energy, one is considered as low grade energy. That is the only difference.
Okay, sir.
Okay.
Okay, sir.
Heat can be transformed into work fully because it is considered as low grade energy. But work cannot be transferred fully into heat.
Okay, sir.
And okay, tell me a few more questions. Okay. What do you understand by work done in thermodynamics? Anybody can give me answer.
So work in thermodynamics is considered when a system can lift a weight.
It can lift the weight when you arrange a pulley, it can lift the weight. So by that means we can understand that in thermodynamics, the work is being done. Okay. Okay. What is latent heat? What is latent heat?
So heat required to change the phase state of the substance without changing the temperature.
Without changing the temperature and only temperature.
Yes, sir.
Is there any change in pressure or not?
No, sir, no change in pressure.
Sir,
Pressure and
energy released by mass.
pressure and temperature both remains constant during the latent heat transformation. Okay. So they both remain constant, only the phase change. Give me the example of latent heat. That means phase change using latent heat.
So ice into water or water into ice at 0 degrees Celsius.
Yes, water into ice or ice into water at 0 degrees centigrade. Okay, or water into vapor or vapor into water at 100 degrees centigrade. Okay, so they both are the example where the latent heat comes into the picture. Okay, due to the latent heat, the phase transformation occurs. Okay, it is a very important thing. Okay, it will be used when we will study the module 3, that is properties of pure substance. At that time, these things will be very much used. Latent heat, enthalpy, phase change. Okay, we will study later. Don't worry about it. Okay. What is zeroth law of thermodynamics? So, Subankar, you tell me what is zeroth law of thermodynamics? Subankar, can you hear me? So, Pratik, you tell me what is zeroth law of thermodynamics?
Sir, if A and B are in equilibrium and A and C are in equilibrium, then sir, B and C would also be in thermal equilibrium.
Thermal equilibrium, not only equilibrium, thermal equilibrium.
Thermal equilibrium. Sorry, sir.
Okay, there is a difference between equilibrium and thermal equilibrium. Okay, so if two bodies are in thermal equilibrium and if one body is in thermal equilibrium with another body and separately with any another body, then they all are in thermal equilibrium with each other. Okay, what is
Sir.
thermometric property?
So properties that depend on temperature.
Sorry, properties. What did you say? Please repeat.
Sir, properties that changes with temperature.
Properties that
are
changes with
dependent on
temperature. That is thermometric property. Okay, more or less you are right. So Give me example of some thermometric property related to particular type of thermometer.
Sir,
What is
gas
the
pressure.
sorry?
The gas pressure.
What is gas pressure? I did not understand.
The example of thermometric property.
This is gas pressure. Gas pressure.
Like in constant volume gas thermometer, the thermometric property is pressure.
Pressure. Okay. And in electrical resistance thermometer, what is the thermometric
The
property?
resistance.
The EMF, electromotive force.
EMF. In electroresistance thermometer, the thermometric property is EMF.
For resistance.
Electric resistance.
It is resistance. What
Okay,
is
sir.
where thermocouple is a thermometric property? In which type of thermometer?
So in thermocouple, EMF is the thermometric property.
In thermocouple, EMF is the thermometric property. By the change in thermocouple, by the change in value of thermometric property, that is EMF, the temperature is measured. Okay. Thermometric property. What is Seebeck effect? What is Seebeck effect? Seebeck effect. It was there in thermocouple. What is Seebeck effect?
So two different conductor having different temperature.
Two different conductor having two different temperature. Then it is a Seebeck effect. What is the
Yes.
effect of that?
So potential difference would vary.
When two metal wires, or you can say two conductors, are joined at two different temperature, then the EMF is generated. Okay, then an EMF is generated, that is known as Seebeck effect.
Okay, sir.
Okay, that is known as Seebeck effect. Okay, on what principle the electrical resistance thermometer works?
So Wheatstone bridge, sir.
Balanced Wheatstone bridge. Okay, balanced Wheatstone bridge. On the principle of balanced Wheatstone bridge, it works.
So could you please repeat about this? So what effects? I got disconnected at the time, sir.
When two dissimilar metals are joined at two different temperature, okay, then a thermal EMF is generated. That is known as Seebeck effect.
So could you please spell it?
Seebeck effect, S-E-A-B-A-C-K, Seebeck effect. You can find the spelling in the book. I may be wrong here. I'm not sure about the spelling. You will find in thermodynamics. Don't worry about it. As far as I remember, it is S-C-A-B-A-C-K, Seebeck effect.
Sir, it is the principle of thermocouple.
The phenomena is known as Seebeck effect. Yes, this is the principle, you can say. Because that thermal EMF that is generated due to which we measure the temperature, no? Okay, one more thing. What is triple point of water?
So triple point of water is like the point where all the states coexist.
All the three phases of water coexist. What is the value of it?
So 273.16 Kelvin for temperature.
273.16 Kelvin or 0.01 degree centigrade. Okay, remember this value, very, very important. Okay, this is the called triple point of water. Okay, so one thing I have understood from this that at least Jinat is studying in her home after the class. She has actually many things in her mind. But Suvankar, oh, sorry, Supratik, I think you are not studying very well. I won't say that you are not studying at all, but still your performance could be much better. Okay, and I expect that from the next session you will respond very well. Okay.
Okay, sir. Thank you, sir.
But remember, just covering the syllabus or module is not enough for me or for you also. Okay, it is not like that I have covered the syllabus and that is enough. No, you will have to write in the exam. No, and this is the only possible when you will study in your home. No teacher can teach you 100% in the class, or just by attending a lecture nobody can get good marks in the exam if he or she does not study in the home. Okay, this class, the lecture is all about giving you some knowledge, some concept, but this thing will be much clearer to you if you study in your home also after the class. So things will be much clearer. You will understand many things, you can correlate. Okay, so this is very important one. So at least I just want to say that कोई भी टॉपिक जब हम लोग पढ़ाते हैं, कोई भी टीचर पढ़ाता है, एक बार उसको घर पे उस जो टॉपिक पढ़ाया है उस पर एक बार रिवाइज जरूर करो. तो उससे क्या होता है ना, वो जो चीज होती है वो काफी लंबे समय तक दिमाग में रहती है. ठीक है, और टाइमली उसको ब्रशअप करना जरूरी होता है दिमाग को, अदरवाइज क्या होगा ना, वो चीज भूलने लग जाओगे. ठीक है, सो विद दिस we have covered, we will start our next module. As I discussed, I will not start module 3, but I will start module 4. Okay, module 4 is important. Then module 3, module 3 is more important, and I want module 3 should be started when the maximum number of students will be there. Okay, and I don't know whether I will get enough time to revise the things or not, so that is why I don't want to take the risk, and I will start module 4 today's class. Okay, so is my screen visible? Okay, is it visible?
Yes, sir.
Okay, so let us discuss about module 4. So module 4 is also the extension of the first law of thermodynamics. Okay, first law of thermodynamics that we discussed today, and this first law of thermodynamics, that how we can apply in many processes that we will study. Okay, before going to this particular module, let us discuss about control volume. All of you know the control volume. What is the control volume? I discussed in the first class of thermodynamics. What is the control volume? What is the control volume? Control volume is the fixed amount of state, or you can say fixed amount. Okay, in the thermodynamic system, or it is a fixed mass where we do the analysis. That is, all the thermodynamic analysis is done that particular fixed region in the space. Okay, fixed region in the space where the thermodynamic analysis is done, like mass or energy transfer, etc. This is known as control volume. Understood? So this thing will be utilized now. Okay, so a fixed region in the space where thermodynamic calculation, energy transfer, mass transfer, that is done. This is known as control volume. So you can see this is a control volume. Suppose this is the turbine. Okay, all of you have the idea about turbine. Turbine is a device by means of which electrical energy is produced. No, when we use water as a working fluid, or steam as a working fluid, or gas as a working fluid, then what happens? This working fluid strikes the turbine, and they start rotating the turbine. And when the turbine rotates, the shaft is connected with the generator, and that generator produces electricity. Okay, so that is the function of the turbine. So in thermodynamics, when you do the energy or mass analysis, you should take any device as a control volume. That means whatever the energy input or mass input is there, and what is the energy output and mass output is there. Okay, one would be inlet, one would be outlet. Based on that, you do the calculation. For example, you can say here the turbine is there. This is the entry point of the turbine, point 1. Okay, suppose steam is coming from this point. So this is the inlet. Okay, and this is the outlet. This exhaust pipe is the outlet. After the expansion of the steam into the turbine, the steam, low temperature steam, it comes out of the turbine from this particular space. So if you take this whole system, okay, this dotted line, you can see this is the control surface, and inside this control surface, the whole thing is taken as control volume. Okay, so this is the control volume example. That means what? We will do the analysis of the turbine. If you want to do the sorry, if you want to do the analysis of the turbine, then we can do by this particular manner. Okay, now you know that is Q equal to delta E plus W. Very, very well known equation to all of you, and you should not forget this equation at any cost. Okay, this is the very basic of a thermodynamics equation, one of the very basic equation. Now E means what? E means energy. E means energy. Okay, so energy could be of what? It could be of stored energy, it could be of macroscopic energy, it could be of microscopic energy. Okay, so you can see E could be many things. EK plus EP. EK means what? Kinetic energy. EP means potential energy. Okay, U means what? U means the internal energy. So this thing all will come under the category of E, that is energy. Now if we take the pure substance where only kinetic energy, potential energy and internal energy is there, and other form of energy such as electrical energy, vibrational energy, etc. are missing, then we just write E equal to EK plus EP plus U. Okay. Now just apply this, just put this value of E, that is EK plus EP plus U here. Then we can find Q equal to delta EK plus delta EP plus delta U plus W. That is change in kinetic energy, change in potential energy, change in internal energy plus W, that is the work done. Got my point? Very easy one. So this is the control volume. This is the just a brief idea about the control volume. Okay, a fixed region in the space where the thermodynamic calculation or establishment, a thermodynamic study is done. Okay. Now, very important one is the steady flow process. What is the steady flow process? The rate of flow of mass or energy across the control surface remains constant. That means what? Whatever the mass input is there, the same would be the mass output, and what is the energy input is there, same is the energy output. That means what? No amount of mass or energy is stored inside the control volume. Did you get my point? Okay, for a steady flow process, suppose ये entry point है 1, ये entry point है, exit point है 2. Now a working fluid is coming in. Suppose m1 kg per second is the input mass. Then for a steady flow process, whatever the input mass is there, this is suppose m1 kg per second is coming in, then this m1 kg per second would be the going out, and suppose the energy which is coming in also with the help of this working fluid, कुछ एनर्जी है जो पर सेकंड वहां पे एंटर कर रहा है, उतना ही एनर्जी पर सेकंड क्या होगा यहाँ से बाहर भी निकल जाएगा. Okay, so at a given instant of time, there should not be any mass or any energy stored inside this control surface. इसके अंदर कुछ भी स्टोर नहीं होना चाहिए, जितना आ रहा है उतना जाना चाहिए. That is the steady flow. Did you get my point?
Yes, sir.
Okay, and when this thing does not happen, suppose mass inlet is more than the mass outlet, or energy inlet is more than the energy outlet. Okay, or anything that happens which is not equal to inlet and outlet, then we call that when we know that process as unsteady flow process, unsteady. But in steady flow, everything should be constant. That is, everything should be same. Input and output is same. At a steady state of a system, any thermodynamic property will have a fixed value at a particular location and will not alter with time. It will not alter with time. All the things will have a particular value. Okay, now for a steady flow process, there should be mass balance is the compulsory. Mass balance is compulsory. How? You can see this is a suppose steady flow device. All the device that we take, that we consider for this thermodynamic study, that we use in our many day-to-day life use, such as nozzle, diffuser, etc., they all come under the category of steady flow device. Okay. So for example, here suppose we have a steady flow device. Now you can see this dotted line is nothing but the control surface. Okay. Now you can see this is the inlet pipe. This one is a pipe through which a flow is coming inside the system. Okay. For example, if you take the nozzle. Okay. If you take any nozzle, in nozzle what happens? The fluid enters the nozzle with less speed, and when it goes out of the nozzle, it has high speed. It is the nature of the nozzle. No, it increases the speed, okay, of the fluid. So in the similar manner, suppose we have a steady flow device, whatever the device it may be, I don't know. Okay, so this one is the inlet. Okay, and this 2 is the outlet. Okay, 2 is the outlet. That is from the point from the pipe 2 the fluid is coming out of this control surface. Okay, now suppose this first pipe is having an elevation Z1 from a reference point. Now suppose this is a reference line, datum. This is also known as datum. Okay, so this is any arbitrary line through which we will measure the height. Okay, so this is an arbitrary line through from which this is the height of the first pipe, that is Z1. This height is used for calculating what? Potential energy. Okay, we know that the potential energy is function of height, mgh. Okay, so that is why this terminology is many times used. And this second pipe is having a height of Z2 from the datum. Okay. Now this is the shaft which is connected with this steady flow device. That means what? This steady flow device will produce some work. For example, it can be turbine. Okay. Now what is the meaning of mass balance? Mass balance means what? The mass coming in per second should be equal to mass coming out per second. You can see by the conservation of mass. Mass balance mass balance means what? You will have to apply the law of conservation of mass. Okay, conservation of mass should be there. What is the meaning of that? No accumulation of mass within the control volume. Mass should not be accumulated inside the control volume. Whatever the mass is coming in, it should be the same mass that is going out. Okay. So if you consider the mass coming in per second is m1. Okay, it is m1, and mass going out per second is m2. Then according to the mass balance theory, for the steady flow, M1 should be equal to M2. Okay, or mass per unit time, that is also known as, you can say, discharge, that is A1 V1 by V1, which is equal to A2 V2 by V2. Okay, okay, this V1 is velocity, this small V1 is volume. Okay, don't get confused. So this should be equal. This is also known as continuity equation. That is the
So what
mass
is A?
area of inlet. A1 is the area of inlet, A2 is the area of outlet of the pipe. Okay. So
Yes, sir.
this is the continuity equation. You will study continuity equation in fluid mechanics in 4th semester. Okay, where this continuity equation will be very much useful for many things that will under the fluid mechanics. The many derivation is also there based on the continuity equation. So what is continuity equation? Is nothing but the mass balance. Okay, that is the mass inlet should be equal
So
to
the
mass outlet.
capital V is the volume, so
Capital V is the velocity. Okay. So this is the continuity equation. Remember this formula: A1 V1 by V1 equal to A2 V2 by V2. Okay. Now let us discuss about energy balance. Same system we have, same datum, same steady flow device. Okay, same shaft. Okay, this is entry point, this is exit point. So what is the energy balance? The energy balance is nothing but energy is also not accumulated inside the system, but whatever the energy that is coming in, it should be equal to going out. Okay. In the meanwhile, you can understand that whenever a device is there, whenever a system is there, when some energy is coming in, some energy is going out, okay, and it is able to perform some work, then definitely there would be heat transfer. Okay, because if the device is not isolated, not insulated, then definitely heat transfer can also happen. Okay, from the system to surrounding, and from surrounding to system. So you can see this is the amount of Q, that is the amount of heat transfer that is taking place between system and surrounding. मान लो Q अमाउंट है का जो हीट है वो आपको सराउंडिंग से लेकर सिस्टम में इन कर रहा है, ठीक है. एनर्जी विच इज कमिंग इनसाइड द सिस्टम इज फ्रॉम 1 गोइंग आउट ऑफ द सिस्टम बाय 2 and as a result this shaft, which is the steady flow device, it is capable of producing some work, Wx. Got my point?
yes, sir.
Okay. Now there are many terminologies that you will have to go through this particular module. Okay, this particular calculation, I would say. Okay, so just look at this diagram. इस डायग्राम को ध्यान में रखो, जो पॉइंट है, उसके बाद हम लोग थोड़ा सा डिस्कशन करते हैं. ठीक है, याद रखो इनलेट पॉइंट 11 है, आउटलेट पॉइंट 22 है, हीट Q है, वर्क W है, एलिवेशन Z1 है और Z2 है. ओके, बस इतना सा याद चीज है, उसको अपने थोड़े माइंड में रखो. उसके बाद हम लोग कुछ टर्मिनोलॉजीज हम लोग उसको देखते हैं. लेट P1 इक्वल टू प्रेशर ऑफ वर्किंग फ्लूइड एट इनलेट. दैट वर्किंग फ्लूइड व्हिच इज entering at that time, at the entry the pressure is suppose P1. V1 is the specific volume of working fluid at inlet. Okay, V1 is the specific volume, that is volume per unit mass. ठीक है, कैपिटल V1 is the velocity of working fluid. वो स्पीड है, उसका वेलोसिटी है, जैसे स्पीड से वो एंटर कर रहा है. U1 is the specific internal energy at inlet, that is joule per kg. Whatever we are doing in terms of specific on per unit mass. Okay, Z1 is the datum height for the first one. ये हमने अभी तक देखा. इतना क्लियर हो गया? Z1 क्या है, P1 क्या है, V1 क्या है, स्मॉल V1 क्या है इनलेट के लिए, समझ में आ गया?
Yes, sir.
अब सेम वही चीज होगा हमारे आउटलेट के लिए. P2 इक्वल टू प्रेशर ऑफ वर्किंग फ्लूइड एट आउटलेट. V2 equal to specific volume, capital V2 equal to velocity, small u2 equal to specific internal energy, and Z2 equal to datum height. Now, if we wanted to apply the conservation of energy here, then what should be our motto? Our motto is that we should equate all the energies associated with the working fluid at inlet and outlet. जो इनलेट में है, जो आउटलेट में, दोनों को बराबर कर दो, तभी तो मास एनर्जी बैलेंस हो गया। ठीक है, तो वही करते हैं अभी हम लोग। अब देखो, फ्रॉम द फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स और फॉर द स्टडी फ्लो एनर्जी इक्वेशन है, जो भी बोल दो, एनर्जी इनलेट एंड एनर्जी आउटलेट बोथ शुड बी सेम। Now, suppose energy inlet, total energy inlet जो हमारा हो रहा है, whatever the total energy inlet, suppose we are representing it with E1 and energy outlet we are representing it with E2. E1 equal to E2. Okay, so E1 मतलब energy inlet. Energy अब कौन-कौन सा हो सकता है? देखो, internal energy होगा, it would be internal energy, it would be flow energy, it would be kinetic energy, it would be pressure energy, and it is also heat transfer at inlet. Outlet में क्या क्या होगा? Internal energy, flow energy, kinetic energy, potential energy और work transfer. Suppose सिस्टम में हमारा हीट आ रहा है बाहर से, तो ये तो इनपुट हो गया, और जो सिस्टम वर्क प्रोड्यूस कर रहा है ये हमारा आउटपुट हो गया। सो इनलेट में हम लोग हीट लेंगे और आउटलेट में वर्क लेंगे। समझ में आया ना?
Yes, sir.
Okay, so now just you can see E1, internal energy is U1, flow energy, that is the displacement energy, that is the PV, pressure volume energy, so it is P1 V1. Kinetic energy half V1 square, because we are taking for per unit mass everything. The formula for kinetic energy is half mv square, you all know, but if we take the mass value as unity, that is 1, that is, then it will become half V square only. Potential energy, you know, it is the formula is mgh, but m we have taken unity, so it is only gh. H means height. Height आप देख लो हमने क्या लिया है, z1 लिया है, so you can see gz1. Okay, and heat transfer is, suppose we are representing with q12. Okay, in the similar manner at the outlet you can see u2 plus p2v2 plus half v2 square plus gz2, and in place of q12 we will write w12, that is the work transfer. Is it clear?
Yes, sir.
Now just look at this term u plus pv, u1 plus p1 v1, एक टर्म है ना यहाँ पे, देखो ये वाला u1 plus p1 v1, can you see it?
Yes, sir.
Now tell me, what is the u1 plus p1 v1?
Sir, heat.
Heat. U plus PV is what? U plus PV is not heat, it is enthalpy. H is equal to U plus PV, no?
Yes, sir. Yes, sir. H was the second.
H equal to U plus PV. So in place of U1 P1, can we write H1?
Yes, sir.
And in place of U2 plus P2 V2, can we write H2?
Yes, sir.
So just replace this U1 plus P1 V1 as H1. So you can write E1 as H1 plus all the things same, that is V1 square by 2 plus DZ1 plus Q12. And similarly, E2 would be what? H2 plus V2 square by 2 plus DZ2 plus W12. Okay, and we will equate both the terms, because this is the condition of what? Energy balance. जितना भी energy inlet पे है उतना ही outlet पे होना चाहिए. That is the same. So now what you will get when you will do so? Okay, then this is the, you will not get anything, but you can see this is the formula, or you can say this is the equation which is known as the steady flow energy equation. Okay, this is the steady flow energy equation, that is H1 plus V1 square by 2 plus GZ1 plus Q1 equal to H2 plus V2 square by 2 plus GZ2 plus W1. This formula will be useful for solving many problems. ओके, यानी हम लोग एनर्जी बैलेंस जब करेंगे स्टडी फ्लो के केस में तो ये वाला इक्वेशन हमको मिलता है. ओके, ये फॉर्मूला इंपॉर्टेंट है, इसको याद रखना. नाउ व्हाटएवर द कैलकुलेशन वी डिड हियर फॉर दैट वाज फॉर द वन इनलेट एंड वन आउटलेट ओनली. यहाँ पे एक ही पाइप है जो इनलेट पे है और एक ही पाइप है जो आउटलेट पे है. ओके, बट इन रियलिटी देयर कुड बी मेनी पाइप्स इन इनलेट एंड आउटलेट एज वेल. ऐसा हो सकता है कि बहुत सारा पाइप इनलेट पे लगा हो, ठीक है, एक साथ बहुत सारा पाइप लगा हो, यहाँ पे 2-3 लगा हो, ठीक है, आउटलेट में भी बहुत सारा पाइप लगा हो, ऐसा हो सकता है. सो अगर हम लोग वैसा केस में अगर इसका कैलकुलेशन करना चाहें तो सेम वही प्रोसेस है, देयर इज नो एनी डिफरेंस. ओके, सो जस्ट लुक एट दैट. यू कैन सी हियर you can see in the control volume all the things are same. Okay, 2 inlets are there and 2 outlets are there. Okay, 2 inlets are there and 2 outlets are there. अगर ऐसा केस में हम लोग करेंगे तो इनलेट को एक सम कर दो. यहाँ पर देखो जो पहला वाला केस था, यहाँ पर जो इक्वेशन था ये वाला देखो, H1 plus V1 square by 2 plus GZ1 plus Q1 equal to सेम. उसको अगर थोड़ा सा और इलेबोरेट कर दे, अगर हम लोग मास से मल्टीप्लाई कर दें, ऐसा भी कर सकते हैं हम लोग. वी कैन मल्टीप्लाई इट विद मास because whatever we have got till now is for the per unit mass. Okay, and if we have a particular amount of mass which is flowing in, and if we know the value, then we can multiply this particular equation with mass also. ठीक है, कितना मास इनलेट पे आ रहा है और कितना आउटलेट पे जा रहा है उसको भी हम लोग मल्टीप्लाई कर सकते हैं. देयर इज नो प्रॉब्लम एट ऑल. सो दिस इक्वेशन कैन बी फर्दर यू कैन से एक्सपेंडेड इन दिस मास मैनर आल्सो. मास के टर्म में भी हम लोग इसको एक्सपेंड कर सकते हैं. ओके, now if you take 2 inlet and 2 outlet, okay, you can see 1 1 2 2 is the inlet, 3 3 4 4 is the outlet. तो कुछ नहीं है, इसमें भी सेम वही करना है आपको. Suppose at point 1 the mass coming in is m1, at point 2 mass coming in is m2 kg, at point 3 mass going out is m3 kg, at point 4 mass going out is m4 kg. Heat transfer is q and work transfer is suppose w. Okay, वर्क ट्रांसफर इज सपोज W. तो यहाँ पे आप ऐसा कर सकते हो कि पहले वाले पॉइंट के लिए m1 से मल्टीप्लाई किया, बाकी जो टर्म है उसको सेम लिख दिया. सिर्फ हीट छोड़ के, हीट को हम लोग एक बार में लिखेंगे प्लस Q, बिकॉज हीट इज नॉट एसोसिएटेड विद दिस पाइप, दिस एनर्जी विच इज कमिंग इन, बिकॉज हीट इज द टोटल हीट दैट इज कमिंग इनसाइड द सिस्टम फ्रॉम एनी अदर सोर्स. ओके, सो m1 into energy at this point plus m2 into energy at this point plus total heat is equal to m3 energy at this point plus m4 at energy at this point plus w also. Okay, यहाँ पे w by mistake छूट गया है मेरा. Okay, plus w भी होगा. Okay, so that is the work done or that is the steady flow energy equation for more than one inlet and outlet of a control volume device or a steady flow device. Okay, अगर यहाँ पे 2 की जगह 3 अगर हमारा इनलेट हो तो भी हम लोग लिख सकते हैं m1 m2 m3 करके. ठीक है, डज नॉट मैटर कि आपका इनलेट कितना है आउटलेट कितना है. जब आपको बैलेंस करना है तो बस इसी तरीके से आपको बैलेंस करना होगा. इट इज अ वेरी सिंपल प्रोसेस. ओके, नाउ वी विल हैव टू अप्लाई दिस लॉजिक, ओके, इन सम ऑफ द स्टडी फ्लो एनर्जी डिवाइसेस. ओके, बहुत सारे डिवाइसेस है जिसमें स्टडी फ्लो एनर्जी इक्वेशन हम लोग अप्लाई कर सकते हैं. तो वेरी फर्स्ट वन इज द नोजल एंड डिफ्यूजर. Nozzle and diffuser are very common thermodynamic devices that are useful in many areas of thermodynamics and in our day-to-day life also. Have you seen a nozzle? सबने देखा है nozzle? Nozzle देखा
Yes,
है या
sir.
देखा है? Where?
हाँ सर, देखा है सर. मशीन
শিলিগুড়ি পুলিশ
ज्यादा।
কমিশনার থেকে
सर, लाइक बहुत सारी जगह
इंस्पेक्टर
नोजल्स होते हैं सर,
मुमताज
लाइक
बेगम বলছিলাম আইসো
पाइप्स वगैरह में भी देखा है.
What is the function of a nozzle? The nozzle's function is what? It increases the velocity of the fluid at the expense of the pressure drop. यानी क्या होता है, कोई भी फ्लूइड जब किसी नोजल में एंटर करता है तो उसका वेलोसिटी कम होता है बट प्रेशर ज्यादा होता है. ठीक है, लेकिन जब वो नोजल से बाहर निकलता है तब क्या होता है, उसका स्पीड बहुत बढ़ जाता है बट प्रेशर क्या होता है, बहुत फॉल कर जाता है. So at the expense of the pressure, the increase in the velocity takes place. This is the function of nozzle. And the diffuser is just reverse of nozzle. जब आपको स्पीड कम करना हो किसी फ्लूइड का तो आप डिफ्यूजर यूज करते हो. यानी at the inlet the speed is very high, at the outlet the speed is very less. Okay, so this is the function of nozzle. In practice, the nozzle which is used in power plant etc., they are generally what? They are insulated. Nozzle जो होता है वो insulated होता है, वो उसमें heat transfer नहीं होता है बाहर से, यानी system और surrounding के बीच में. So you can see here, for per unit mass, if we apply the steady flow energy equation here, okay, if we apply here H1, that is H1 plus V1 square by 2 plus GZ1 plus dQ by dm, that is the heat transfer per unit mass, equal to H2 plus V2 square by 2 plus Z2G plus dW by dm. ये अगर हमारा इक्वेशन है, यहाँ पे dQ by dm को हम लोग 0 पुट कर देंगे. क्यों? क्योंकि अगर हमारा नोजल इंसुलेटेड है, if it is insulated, then that is there is no heat transfer taking place, then we can put this dQ by dm as 0. Then we will put dW by dm also 0. Can you tell me why we will put dW by dm as 0? dQ by dm तो 0 हमने पुट कर दिया क्योंकि nozzle is insulated. We are assuming, we know that nozzle is insulated, so heat transfer from system to surrounding is not possible. So we have put dQ by dm is 0 because Q is 0. But why do we put dW by dm equal to 0? You can see here in this line it is written dWx by dm equal to 0. Why do we put dW by dm equal to 0 for nozzle?
Sir, because steady flow process है, sir, ये work done
स्टेडी
zero
फ्लो
है.
प्रोसेस में तो क्या होगा? स्टेडी फ्लो प्रोसेस में तो मैंने कभी नहीं बोला कि वर्क डन 0 ही होगा. Remember, nozzle and diffuser, they are not work producing or work consuming device. Okay, it just changes the velocity by the expense of pressure. एक increase करता है, एक decrease करता है, that is all. ये work produce नहीं करता है nozzle. टरबाइन जो होता है वो वर्क प्रोड्यूसिंग डिवाइस है, वो वर्क को प्रोड्यूस करता है. Okay, if we do the analysis of the turbine, then we cannot put dW by dm equal to 0 because turbine is a work producing device. But when we take the nozzle, we will put dW by dm as 0 because nozzle does not produce any work. Got my point? It is not a work.
Yes,
It is not a work producing device or consuming device. Both nozzle and diffuser. So that is why we can put dW by dm as 0 in case of nozzle. Okay. अब यहाँ पे देखो एक चीज और देखो, यहाँ पे अगर हम लोग एक रेफरेंस पॉइंट यहाँ से लेते हैं, सपोज ये वाला यहाँ से हमारा डेटा में, ये इनलेट का पॉइंट है, ये आउटलेट का पॉइंट है. तो ये वाला हाइट हमारा सपोज Z2 है, ये वाला हाइट हमारा Z1. तो Z1 और Z2 दोनों इक्वल है या नहीं है?
हाँ सर.
है ना? सो इफ वी डू द एनालिसिस हियर, ये dQ by dm 0 हो गया हमारा, ये 0 हो गया. Z1 और Z2 दोनों इक्वल है, तो ये और ये आपस में कैंसिल आउट हो गए. समझ में आया? तो बचा क्या हमारे पास? H1 plus V1 square by 2 equal to H2 plus V2 square by 2. Got my point? So
Yes,
H1 plus V1 square by 2 equal to H2 plus V2 square by 2. अब कंटिन्यूटी इक्वेशन अभी थोड़ी देर पहले हमने पढ़ा, उसमें क्या था? That is mass flow rate should be what? Constant. That is A1 V1 by V1 equal to A2 V2 by V2. Okay. Now यहाँ से देखो H1 equal to H2 plus V2 square by 2 हम लोग यहाँ से लिख सकते हैं, सिर्फ इसलिए क्योंकि अगर हम लोग नोजल का केस लेते हैं if we take the nozzle only, अगर हम लोग नोजल का केस लेते हैं तो नोजल में तुम देखो, अगर ये वाला टर्म हमारा कैंसिल कर दिया हमने, ये वाला कैंसिल कर दिया, ये वाला कैंसिल कर दिया, दिस टर्म्स आर कैंसल्ड आउट, रिमेनिंग टर्म इज h1 plus v1 square by 2 equal to h2 plus v2 square by 2, यही बचा ना. Now the thing is that what is the function of nozzle? What I said, मैंने अभी अभी बोला nozzle का काम क्या होता है, वेलोसिटी को इंक्रीज करना. So at the inlet of the nozzle, the velocity of the fluid is very less, and at the outlet of the nozzle, the velocity becomes very high. So this v1, that is the velocity, in comparison at the outlet is very small. ये जो v1 है, ये v2 के comparison में क्या है, बहुत कम है, because this v1 is the inlet velocity. समझ में आ रहा है ना? So that is why this v1 can also be taken as 0 with respect to this v2. Understood? So अगर आप लोग इसको भी 0 लेते हैं तो हमारे पास फाइनल इक्वेशन क्या बच जाएगा, h1 equal to h2 plus v2 square by 2. Okay, h1 equal to h2 plus v2 square by 2 here. Or from here we can find out v2 is equal to 2 into h1 minus h2 meter per second. This is also one of the very important equation for the nozzle. Nozzle का अगर आपको velocity निकालना है किसी डिवाइस, किसी फ्लूइड का जो नोजल से पास हो रहा है, and at the inlet and at the outlet आपको उसका एंथैल्पी पता है, so you can find it out by using this formula, that is root 2 into h1 minus h2 meter per second. This is the very important equation in for the nozzle. समझ में आया सबको?
Yes, sir.
Okay, so this is the condition of nozzle. Now there is another device which is known as throttling device. This throttling device are used in many places. Okay, in refrigerator also throttling device is used. Okay, same. अब throttling device का काम क्या होता है? Throttling device में throttling process use होता है, ठीक है? इसमें क्या होता है? What happens here is that this fluid comes inside the system and यहाँ पे एक valve है, तो बहुत छोटा सा जो passage होता है उसके through fluid pass होता है हमारा, and this is also the insulated device. Okay, this is also the insulated one. That means what? The device does not transfer the heat from system to surrounding, and this throttling device also does not produce any kind of work. So for throttling device also we can write dq 0 and dw equal to 0. So if you just use this particular equation, h1 plus v1 square by 2 equal to h2 plus v2 square by 2. Okay, मतलब अगर हम ये स्टैटिक फ्लो एनर्जी इक्वेशन अगर आप यूज करो थ्रॉटलिंग डिवाइस के लिए तो वो रिड्यूस होकर यहाँ तक आ जाएगा, जैसे हमारा नोजल के केस में आया था, सेम वैसे ही आ जाएगा. h1 plus v1 square by 2 plus equal to h2 plus v2 square by 2. Understood? यहाँ तक समझ में आया ना? कोई दिक्कत तो नहीं है?
No, sir.
Now this throttling device has one important property that we should consider, that what? The fluid velocity in the throttling device is remains constant throughout the process. यानी जिस स्पीड से ये फ्लूइड यहाँ पे एंटर करता है 1 पे, उसी स्पीड से यहाँ से बाहर निकलता है इस थ्रॉटलिंग डिवाइस पे, ठीक है? So if it is equal, then can we write v1 is equal to v2? अगर इस इक्वेशन में अगर हम लोग v1 equal to v2 पुट करें, so then this v1 square by 2 and v2 square by 2, they both will cancel each other. Am I correct?
Sir, in throttling device, sir, outlet और inlet velocity same ही रहेगा sir हमेशा.
Throughout the device, it almost remains same. क्योंकि इसका प्रोसेस होता है बहुत स्लोली होता है. नोजल में तो हम लोग क्या करते हैं, उसका काम ही है कि वेलोसिटी को इंक्रीज करना. समझ में आया ना? But in throttling device, the function is not to increase the velocity. Okay? When we will study the refrigeration effect, वहाँ आपको throttling device थोड़ा और better समझ में आएगा, मैं उस समय समझा दूँगा, ठीक है? But here at the inlet and outlet, the velocity remains same. What my point? अगर v1 square
Yes,
by
sir.
2, अगर v1 और v2 दोनों इक्वल है, if it is equal, then we can cancel these two terms, v1 and v2. ये कैंसिल हो गया, बचा क्या फिर? बचा हुआ चीज क्या है हमारे पास? h1 equal to h2.
Sir, enthalpy.
That is h1 equal to h2. यही हुआ ना हमारे पास जो बचा हुआ इक्वेशन में से टर्म्स.
Yes, sir.
So what does this mean? इसका मतलब क्या हुआ? If h1 equal to h2, that means what? Enthalpy remains constant. जो enthalpy इनलेट पे है वही आपका आउटलेट पे भी हो गया. Yes or no?
Yes, sir.
So in throttling device, enthalpy remains constant. For in throttling process, enthalpy remains constant. For throttling is an isenthalpic process. ये याद रखना बहुत इंपॉर्टेंट है. बहुत बार ये क्वेश्चन पूछा जाता है कि थ्रॉटलिंग प्रोसेस में कौन सा प्रॉपर्टी कांस्टेंट रहता है. ओके, ऑप्शन देगा आपको प्रेशर, एंथैल्पी, टेम्परेचर एटसेट्रा. सो हमेशा याद रखना इन थ्रॉटलिंग प्रोसेस एंथैल्पी रिमेंस कांस्टेंट. ओके, ये रहा, यहाँ पे देखो लिखा हुआ भी होगा. Often the pipe velocities in throttling are so low that kinetic energy terms are also negligible. यानी क्या होता है, वेलोसिटी इतना स्लो होता है कि हम लोग मान लेते हैं कि दोनों वेलोसिटी बराबर है. ओके, ये v1 स्क्वायर बाई 2 v2 स्क्वायर बाई 2 क्या है यहाँ पे? ये जो टर्मिनोलॉजी है v1 स्क्वायर बाई 2 v2 स्क्वायर बाई 2, ये क्या है? काइनेटिक एनर्जी है ना, पर यूनिट मास. ओके, अब वेलोसिटी इतना स्लो रहेगा कि हम लोग मान लेते हैं कि ये जीरो है, ऑलमोस्ट जीरो है, बिकॉज काइनेटिक एनर्जी इज फंक्शन ऑफ व्हाट? Kinetic energy is function of velocity, and if velocity is very small, then what is there? Then we can assume it is a zero, although it is not 100% zero, but we assume that it is a zero. तो इसलिए हम लोग अपने कैलकुलेशन में इसको जीरो ही मान लेते हैं. ओके, और जो प्रोसेस, अगर जो वेलोसिटी होता है वो बहुत स्लो होता है यहाँ से यहाँ जब वो एंटर करता है और जब वो बाहर करता है, तो ये जो थ्रॉटलिंग प्रोसेस ही होता है, मतलब बहुत स्लो वेलोसिटी. ओके, सो अगर हम लोग इसको जीरो मान लेते हैं तो h1 इक्वल टू h2, और इसका फाइनल कंक्लूजन ये है हमारा थ्रॉटलिंग डिवाइस का. सो एंथैल्पी ऑफ द फ्लूइड बिफोर थ्रॉटलिंग इज इक्वल टू एंथैल्पी ऑफ द फ्लूइड आफ्टर थ्रॉटलिंग. दैट मींस व्हाट? द एंथैल्पी रिमेंस कांस्टेंट और इट इज इन आइसेंथैल्पिक प्रोसेस. ओके, उसके अलावा कुछ और डिवाइसेस भी है, टरबाइन, कंप्रेसर, ये सब हम लोग अगले क्लास में देखेंगे. ओके, सो वी विल डू द स्टडी फ्लो एनर्जी इक्वेशन application on these devices in our next class. Now please, if you have any questions regarding today's class, please ask me. कुछ पूछना है आज की क्लास में?
No, sir.